In this video, we are going to discuss two-dimensional arrays. Previously, all arrays we have worked with have been one-dimensional. The difference between one-dimensional and two-dimensional arrays can be seen here. Notice a one-dimensional array consists of only one row of elements, whereas a two-dimensional array consists of multiple rows of elements. The number of rows and the elements contained in each row is determined when the array is instantiated. Looking at the two-dimensional array in this example, an array of 2 rows has been instantiated, and each row consists of 3 elements. Therefore, the two-dimensional array has a total of 6 elements. The total number of elements can be easily determined by multiplying the number of rows by the number of elements in each row. The number of elements in each row can also be considered as the number of columns in each row. Now, we could have simply created a one-dimensional array to hold 6 elements, as seen in the one-dimensional array, and had a very similar data structure. However, using a two-dimensional array allows us to separate the data being stored in the array into rows and columns. Now, a two-dimensional array can be instantiated in a couple of different ways. The first way to instantiate a two-dimensional array is by typing int, followed by 2 sets of brackets, then the name we want to assign to the two-dimensional array. In this example, we will call the two-dimensional array grid. As mentioned when discussing the instantiation of a one-dimensional array, putting the brackets on the right side of the array name instead of the data type will have the same functionality. I'll go ahead and put the brackets next to the data type. Next, we will instantiate the array to have 2 rows and 3 columns by typing new, as arrays in Java are objects and all objects must be instantiated using the new keyword, followed by the array data type, then the number of rows in the first set of brackets, and the number of columns in the second set of brackets. Now we have instantiated a two-dimensional array that was assigned a name of grid and has the size of 2 rows and 3 columns. Therefore, this array has a total of 6 elements, which can be determined by multiplying 2 times 3. Now that we have instantiated the two-dimensional array, we will need to assign values to or initialize each individual element in order to make this array useful. There are a couple of ways in which this can be done. The first way would be to explicitly assign a value to each individual element. That will look something like this. If you remember, array indexes begin at 0, therefore since we instantiated an array containing 2 rows, the rows will be represented by indexes 0 and 1. And since we instantiated the array to contain 3 columns, the columns will be represented by indexes 0, 1, and 2. So looking at the assigning of values to each element, the element of the first row in the first column is referred to by grid 0, 0. The element of the first row in the second column is referred to by grid 0, 1. And the element in the last or third column of the first row is referred to by grid 0, 2. The same convention is used to assign values to the second row of the array, with the only difference being the index of the second row being 1. We can then print the contents of the two-dimensional array by using a couple for loops. The outer for loop will iterate through the rows of the array, while the inner nested for loop will iterate through the columns of the array. Within the print statement, we will use \t to append tab spacing after each element is printed for a clean printout to the console. Also, we will use a print line statement to jump to the next row when all the elements of one row have been printed to the console. If we run the program, we get 2 rows of data printed to the console. The first row contains the values 0, 1, and 2, and the second row contains the values 3, 4, and 5. Obviously, this isn't a very efficient way to assign values to each element of the array. A more efficient way would be to use a couple for loops. The outer for loop will be used to loop through the rows of the two-dimensional array. Notice the number of rows can be referenced using grid.length, and the nested for loop will be used to loop through the columns of the two-dimensional array. Notice the number of columns is also referenced using the .length method. However, the .length method is used on the grid row index instead of on grid itself. Take some time to process this if it doesn't make sense to you at first. Finally, the contents of the array will be stored by using the following statement. Once again, take some time to process this statement to get a good understanding on what is occurring in each iteration of the for loop. If necessary, use a pencil and paper to simulate each iteration of the for loops to see what the values of I and j are throughout the execution of the for loops. You can also use a debugger, however using a pencil and paper may assist in obtaining a better understanding. We can use the same for loops to print the values of the array to the console, and you can see we get the same exact outcome as we did using the first method to assign values to each element. Now, the second way to instantiate a two-dimensional array is by assigning values in the instantiation statement. So if we get rid of all this code, we can instead assign values by including the values here within braces. Notice we have a set of outer braces, and within these braces are two more sets of inner braces, which both contain 3 values each. Similar to the first method, this instantiates a two-dimensional array of 2 rows, identified by the fact that there are 2 inner sets of braces, and 3 columns, identified by the fact that there are 3 values within each inner set of braces. This instantiation produces the same outcome as the previous method, and this can be verified when we run the program to print the two-dimensional array to the console. We could make this a little easier on the eyes by putting the second set of inner braces or the second row of elements on a new line like this, and we will get the same result when printed to the console. We can also add another row of elements by including another set of inner braces like such. Also note that each row does not have to contain the same amount of columns. For instance, we could add one more element or column to the first row and 3 more to the last, and when we print the two-dimensional array to the console, we get exactly what you would expect with no errors.